Hello friends, welcome back to the channel. VLSI design is very complex, so a process is required to check the correctness of the VLSI design. Now VLSI verification is a way by which you can check the correctness, and VLSI design verification is basically used to check the functionality of the chip before it is manufactured or fabricated. VLSI design verification is a long and time consuming process. It takes sometimes months, and so there is a efficiency boost up is required, and also the correctness of VLSI verification is not always correct. So artificial intelligence is basically being thought of to aid VLSI design verification process, to speed up the VLSI design verification. So whatever is being possible in months, that could be done in weeks. And also the correctness of the VLSI design verification can be improved with the help of artificial intelligence incorporation. So in today's video I talk about, or we can discuss about, the VLSI design verification process with AI guided approach. In VLSI design there are millions of transistors in a particular chip, so the design is very complex. So it is utmost important to find out the correctness of the functionality of the chip. Otherwise, what happens if any error is ignored at the design and verification process, the chip can be manufactured or fabricated, but there will be a flaw in the chip, and that will require the whole respin of the chip designing and manufacturing process. Now, manual checking is done for VLSI verifications for all those interactions of individual transistor in a particular chip, but that is very tedious. So that's why it very long and time consuming process. But if artificial intelligence is being used, which can verify the chip himself with the help of a different technique, then it can be improved. Now, how artificial intelligence can be used? Artificial intelligence can be used by guiding the artificial intelligence about the VLSI design information and design pattern to the artificial intelligence, and also the previous chip, how it has behaved with respect to verification. Is there any error which has been identified? Is there any corner scenarios? Those things are feed up to the artificial intelligence. Now, machine learning is a technique by which artificial intelligence, categorize this automation of the VLSI design verification. Now, machine can be trained with the help of all the previous error, all the history, the design patterns. So for example, if you have a chip 1.0 which you have already verified, you know what is the experience you have got with the help of with chip 1.0. Now, if chip 2.0 is basically being designed and verified, then you can train the machines that, okay, I have this kind of blocks. There can be some common blocks, like you have some bus interface, you have some processor, some other logic units, then you have some memories. So for these individual blocks, if you can train those individual blocks to the machine, so that in designing chip 2.0, which comes after chip 1.0 manufacturing and can have some incremental change but not any major change in the chip 2.0 with respect to chip 1.0, then you can directly employ these already trained machines to the chip 2.0, and that can easily verify what are the incremental change it can identify, and the existing change it can already check with the help of machine learning. Not necessarily a transition from chip 1.0 to chip 2.0. Any kind of chip, you will have these common logic units, you will have processors, you will have the memories, and then bus interface. So any kind of chip has these common blocks inside the SoC. So in new chip, you can for a particular technology, if you use some 4 nanometer technology or 3 or 2 nanometer technologies, you can feed this information to the new chip when you are building it with the same technology. So machine learning can help to identify the flaws, the corner scenarios, and all these things for the new chip are being fabricated. That is one part. Second part is basically you can also use the machine learning and artificial intelligence for for designing the test cases for a particular chip. Now, what are those test cases? Test cases basically gives a test coverage for the whole designs. Now, for a new chip where most of the portion of the chip are being uncovered, it is possible to give a test coverage by doing human generation of the test cases. But there will be some corner scenarios in the chip design which will be left unattended. Now, this machine learning and artificial intelligence can help build test cases automatically for these corner scenarios, so that you will get maximum test coverage up to around 100% for the new chip that you are doing verifications. So more coverage you get for the chip design verifications, more is the chance your chip are correct, fundamentally correct, and you will get a chip fabricated at the end of the chip design flow from RTO to GDS2. In that way, the artificial intelligence and machine learning can help the chip design verification. Now, what is the way of real-world impact of artificial intelligence in design verification or chip design verifications? Now, there are two type of companies. The giant companies, they can easily train the artificial intelligence models with the help of their previous experience of the chip already fabricated in this organization. But the thing is that this training is basically very costly for artificial intelligence. So you may require a lot of GPUs for training artificial design model for a particular chip. But for small companies, there is an advantage that these models, these artificial intelligence models are open source, so they can leverage these open source models to train the artificial intelligence with the help of this chip design. So in that way, artificial intelligence and machine learning are being employed in big chip design giants and also the startups. But the thing is that PLSI design verifications and the chip design artificial intelligence are still evolving. So today's algorithm of designing and modeling a particular chip with the help of artificial intelligence may not hold true for tomorrow's scenario. So since the algorithm are also evolving, so there is a scope of improvement of automating the chip design verification process with the help of artificial intelligence. So till now we discussed about design verifications and artificial intelligence incorporation of the design verifications. Now, what is your thought? If you are an electronic engineer or a semiconductor professional, or you actively doing chip designing, and or you have already a professional who knows about artificial intelligence and you are employing artificial intelligence in the chip designing process, so please provide your thoughts about these things, and how do you think that this video have really purpose to these things. So please drop some comments in the video, and I will try to go through these comments and try to discuss in my next videos for that. And if you have liked this video, please subscribe it so that you can get similar videos in future on chip design verification, artificial intelligence, semiconductor, and all those things. And last but not the least, I would like to share that I have recently authored a book called Semiconductor for All. It is particularly catered for AI enthusiasts and the semiconductor enthusiasts. So if you are interested about this, you can buy this book in Amazon. I will provide the Amazon link in the description section of this video. So get ready for the next video. Till then, Subhasish Chakraborti signing off.